Anyway, Ian, if it's okay for you, for me, we can begin.
Yeah.
Even if we are good, but we are fewer, but we are good. So
We're
it's okay.
recording. We're a little bit off of our normal time, so it may be a little light, but we're gonna get some good stuff.
Yeah.
If you want to, everybody, Giuliano, Nicoletti, and I'll let you have the floor. If you could, please, it's an open format, so feel free to pop in with a question if you have one, but just make sure that if you're not me or Giuliano, that you're muted as we're getting started, just so we've cut down on the dog barking and the customers jibber jabbering and all that kind of stuff. So, all right, are you ready?
Of course.
Giuliano Nicoletti.
Thanks, Ian. So today we are going to talk about acoustic guitars measurement tools for the repair shop. And it's the second time that we talk about this topic. And today we're going to be focusing on the repair shop, what you can do with acoustic measurement tools, and how to profit of the new technologies that are available today, the new technologies and the knowledge that is available today for the everyday work. So, share the screen.
Oh yeah, I'm sorry. I took the screen share off.
No, it's okay. It's okay for me. I just have to go in the right direction, maybe. So, in fact, maybe it's okay for me. Too many screen in front of me. So if I share, and of course my computer decided to go crazy. Screen sharing has failed to start.
Let me see here. We should be good. There we go.
Yeah, maybe. Okay.
We're good.
So, about measuring guitar performances, in fact, this is a paradigm shift. This is something really new in the market. And in fact, the big makers are not devoting energies and time in this type of approach to the instruments, not on the R&D and not even on the communication, of course. So this is something that still it is not used by the big companies. Professionals also. There are not a lot of builders that are actually using measurement tools and new technique to develop and to produce acoustic instruments. And it's just some of the most advanced builders in the world, in fact, that today are spending time and energies to profit of the new technologies. Of course, this gives us a lot of opportunities because, in fact, people are interested in new things, and today there is more information going on with networks, social networks, and also publications, and we see more and more in people that are building guitars that are communicating about this. And some builders are beginning to publish specifications of instruments such as frequency response and main parameters. And the customers are interested because, in fact, we begin to see that with the curve, with the frequency response curve, and with the parameters, we can communicate about performances and sound of an instrument more than what we can do with just a specification of woods or dimensions of the instrument. So this gives us a big, an important possibility also on the repair shop. Because in fact, this type of tools are not expensive to begin with, doesn't take a lot of space, and they offer a lot of possibilities and can help to build customer loyalty, of course. The negative points that I see today is, of course, it requires study, it requires experience, applications, and it has to be explained also to the customers, because there are people that are getting into this kind of things already, customers and passionate people, but for the majority, still, this is something new. So of course it takes time to talk to the customers, to explain what we can do and what are the benefits of using this kind of techniques and tools. So what can we do with a technical approach? I would say, generally speaking, the technical approach is not just, the Trevor Gore model tuning that we often talk about. It's not just that, it's really considering the acoustic instrument as a system that has rules. And these rules, in fact, are dictating the sound that is produced by the instruments. And if we know how the system works, we can, in fact, shape and master the sound of the instrument. So the first data, the most important one, of course, is the frequency response of the guitar. Of course, we are talking about acoustic guitar today, and we are talking about acoustic instruments. The frequency response is giving us a lot of information, and we can use this info for everything related to small modification tuning, that it is the daily life of a repair shop. We can use the frequency response analysis to double check problems with Wolf notes and to tune Wolf's notes. And also when we have problem related to high frequency resonances that sometimes can happen, we can use this approach to understand what is happening and to understand how intervene and where, of course, with what kind of interventions. The second analysis tool is the visualization of the Chladni patterns. It is interesting because together with the frequency response, knowing how the soundboard is resonating and with what shape of the soundboard is resonating can help us to intervene for some tuning and for taming of resonances. Of course, we need to know what part of the soundboard are producing producing acoustic energy if we want to damp or decrease a little bit some resonance. And also troubleshooting, because also for troubleshooting it's interesting to understand what part of the soundboard is vibrating, because very often rub and bats comes from vibrations that are activated by, in fact, actual resonances of the soundboard. And the last but not least, the measurement of the monopole parameters. It's useful when there are big interventions to be done, as soundboard replacement, for example, restoration, repair of bracings. The monopole parameter gives us a clear picture of the type of instrument that we are operating on, what kind of performances, and gives us information about how to replicate that kind of performances. Sometimes it's not easy because it's clear that if we are changing a soundboard, it's very probable that the soundboard is not in good shape. And so measuring the parameters of a soundboard but that's in better days can be quite tricky or impossible. But anyway, knowing and having the possibility to measure the monopole parameters is technically very simple. We will have a look at it and can give us a lot of information about the type of instruments that we are working with. So a lot of things that we will see today, we already discussed in a previous meeting. Today we are really focusing on this type of intervention that are specific to the repair shop, and this is why I really ask you to intervene, to share your opinion and questions, of course, because my experience with the repair shop is very limited. So it's really up to you to take the words then and let me know how we can really focus the intervention, because generally speaking, we will see some example of what we can do, but it's having an idea of the whole matter that is important, what we can do and how we can use this type of knowledge and equipment and tools for our everyday job, keeping in mind that it is really changing very, very quickly. And in my opinion, today it's really the moment where we can profit of being there and being the first to use and apply this kind of techniques in our everyday work. It's okay?
Yes, sir.
I proceed. So just a quick reminder of the frequency response graphic. How can we read it? So we have in the y-axis the dB/SPL, it's the sound pressure level, how loud a sound is. On the horizontal axis, it's the frequency. So at the left, we are at low frequencies. On the center, we have mid frequencies. And on the right, we go towards high frequencies. And in this graph here, I reported also the first 6 fret of the 6 strings on the top of the graph. And you can see that the main resonances of the instruments are positioned really on the center of the frequency range that the notes of the fretboard can produce. And this is, of course, very reasonable, because, in fact, the resonances of instruments are producing sound. We want the resonances to and the sound box of the instrument to amplify the sound. And this is why, in fact, the resonances are really centered on the frequency range of interest. And these resonances are almost always in similar places of the graph. And this is why an acoustic guitar sounds like an acoustic guitar. In order to measure a frequency response, we need a very simple system, just a microphone, an impact hammer, and an FFT analyzer. These are the ones that I suggest to use because they are very high performances, not expensive. And the procedure is quite simple. There are not standard still on how to measure the frequency response of an acoustic guitar. This is something also where, Ian, I think that we could start thinking and discussing, because proposing a standard is the first step to really start diffusing a technique. And the fact that on the acoustic guitar industry, there is not one big association with the big names that can, in fact, propose commissions to define standards. It's not helping. But if we are big enough, if the association that can propose can begin working on this is big enough, and if we are able to create a work group, a commission that is interested in, and how do you say, I don't have the name, but if we are good, we can start thinking about proposing a standard for this measurement. And the standard can of course incorporate the position where you can tap, the instrument that you have to use, how many averaging, the distance, all that is needed to make a measurement repeatable.
So if I get you right, what you're proposing standardizing is like, the tool that you use to strike the guitar, and the distance from the microphone, and the microphone that you're using, the software that you're using. I would say I don't think you necessarily need to be big. You would be the only one doing it at this point, and I don't know why anybody would deviate and have to recreate data and just reinvent the wheel. I think.
Yeah, the
I think
problem is that
by virtue of the
problem
fact
is that the problem is that there are a lot of small research center all around the world.
Mhm.
There is one in France, which is ITEM, which is connected to the University of Le Mans, which is it's a very good research center facility. There is the VSA Oberlin in the US, together with the JASA, the Journal of Audio Society, and there is Cardiff University in England, and each academy, if you want, propose not always different, but different, in fact, way to get this data.
Yeah.
And yes, of course, in my book, I am proposing something, but what would really change the situation is a community which starts using this standard and start communicating, start sharing about this, discussing also, changing, modifying something. So this is something that we can talk about. It was just to introduce you.
Yeah. Well,
the method.
So in terms of the standards of the industry, for instance, I don't think there is one for steel string acoustic guitars. Like, I don't think anybody in repair or restoration is dealing with this. And I run into guitars, frequently, especially from older Gibsons, that obviously have some resonance issues, and it makes them, in my experience, I find them difficult to tune, just because it seems like they've got resonances that are conflicting with what the strings are doing. So
Yeah.
Anything that started the ball rolling in the direction of sorting that out, I would say I would be an early adopter of whatever that standard is. So that makes sense.
Okay. So when we have a look at the frequency response curve, we see that we always have the first A resonance. It's the first peak, always. Then we have always a second peak, which is the monopole. Also here, always. Microsoft doesn't allow me to open the file. I don't know why, because it was opening it. But anyway, we can go look for it. And it was monopole. So this is the monopole of an acoustic guitar. Here we can see this is a simulation of a guitar similar to a Martin with an X bracing style. But anyway, the monopole is always very similar. It's really the central part of the lower bout of the soundboard, which is resonating. The center of the monopole is the bridge. And this is the most important resonance of the instrument, because it has the higher SPL, the bigger radiating surface, and because it is also omnidirectional. So it's really something like a pulsating sphere. And this is why when this resonance is really the biggest one in the instrument, and the bracing system is designed to produce a powerful monopole, the instrument is really projecting a lot. And this is the case, for example, with archtop guitar that have a very powerful monopole, with a classical guitar with lattice bracing, for example, that are designed for the concert hall. And this is the most important resonance of the instrument. And also, if you look at here, you understand why when you change something in the bridge, the effect on the frequency of the resonance is very direct, because you are exactly on the center of the monopole, of the pole that it is emitting surface. So when you change, for example, the saddle, the pins, when you install a pickup system, you are exactly at the center of the monopole. And this is why just a few grams of difference can shift and can make a difference on the sound of the instrument. So this is the the monopole. And in the frequency response, it's the second resonance usually. And then if the back is active, we can see a third resonance, which usually it's lower in amplitude compared to the monopole. And then we have other high order resonances, the dipoles and the tripoles. In the X-braided Martin style, the long dipole and the cross dipole are very close in frequency. In fact, this should be higher. But anyway, what we can see from this picture is that usually when we see a peak, we have a specific resonance of the soundboard. And with a little bit of experience in a similar type of instrument, we will be able to recognize very quickly what are the modes of the soundboard that are producing peaks and SPL and sound, of course. So with just a very quick measurement, we can have a direct indication of the type of sound that is produced by the instrument. If it has a lot of bass, if it is a projecting instrument, if it's on the mid-range type or some blues guitar type, or if it is something more adapted to finger picking, for example. The visualization of the cladding patterns is also quite simple. You just need an application that can produce frequency tones, a Bluetooth amplifier, or recently I am also using this kind of Bluetooth speaker, which are still more simple to be used because they are on battery. So you have a battery, no cables, and usually with the GBL Flip 5, you have a system that it is powerful enough to visualize all the modes of interest. So it's something also that you can consider. Anyway, it's inexpensive equipment, and the way you use it is like this. Oh, this works fine. Of course, Oregon leaves. It's important to have the right flavors on the shop. A speaker. I don't hear sound. Maybe I didn't activate the sound, but anyway, you see that with the phone, with the application on the phone, I am changing the frequency. And changing the frequency, I can highlight different modes on the table using a speaker which is held at a couple of centimeters from the soundboard. And this way, I can very simply double check what peak is related to what kind of resonance mode on the table. This is the cross tripole, for example, and it's very simple. In fact, it's very simple, and this is powerful in the repair shop because it gives us the possibility to really see on the soundboard at that frequency what part is vibrating, what part is not vibrating, and where I can go to look for problems, or where I can intervene to lower the vibrations and also the SPL of the system of the soundboard.
Hey, Giuliano. Well, doing those kind of measurements on a guitar that's already built,
Yeah.
Like a customer's guitar being brought into the shop, it wouldn't necessarily be easy to set that up on a table with the guitar with the neck on it and all that. Would the same type of measurements be able to take place if you chucked up a guitar in a vise with holding onto the neck, or no?
It's the same.
Okay.
In fact, I am proposing you this video because I have this video, but you can do the same thing with a complete instrument, and you don't even need to remove the strings. In fact, the less you touch from playing condition, the better it is. The only thing is that really it has to be horizontal, the soundboard, of course. But then, yeah, and of course, if the back is active, also you need to leave it free. In this case, you see that there are some spacer from the table.
Right.
Can I?
Because the modes are the back and the top are influencing each other, so you don't want to dampen the back.
Does anybody here need any extra explanation on how the patterns on the resonance on the top relate to the graph on the computer? Is everybody clear on that?
No, I'd love to know.
Okay.
Okay, in fact, I have
Giuliano, did you?
yes.
Okay,
Yes.
okay, yeah, okay.
Yes, this is a nylon string guitar with a bracing, a fan bracing, similar to fleta style fan bracing. You have the first peak, as I said, it is always the resonance of the air within the box. It's the first mode that we call T111, and of course. I didn't put a picture of the first mode because it's very similar, in fact, to the monopole. It's really the whole body which is pumping and resonating with the air, but the sound, the SPL, is not produced by surfaces, but it's produced by the hole, by the opening, and in fact, for this first mode, the spring of the system is the air inside the box. And the mass is the mass of the air which is in the hole. Even if the hole is very thin, it has a mass. It has a volume and a mass. So the first peak is not present because it's not directly the soundboard. But the second one is always the monopole. It's here, you can see it. And we saw the simulation, and we also, oh, it works. Nice. No, it's not exactly. No, it's not exactly the same. But I already show you what a monopole look like, and it's the lowest frequency mode. Just because, in fact, you have to imagine that sound waves are reaching the soundboard through the bridge and are traveling inside the soundboard from one edge to the other. And at a frequency which is dictated by the dimensions and the stiffness and the density of the soundboard, you will have a standing wave and this type of mode. And the monopole is the biggest one, so it's always the lowest frequency. And then when you go higher in frequency, you have a fractioning of the guitar, which is always proceeding in numbers. In fact, you have the dipoles first. It's after it's not just like counting 1, 2, 3. You have the dipoles, and then you have the tripoles. In this case, we see that the two dipoles, this one, the first is the cross dipole, and the second is the long dipole. The positioning of these dipoles, it's not always the same. It depends really on the bracing system. In this type of instrument, with fan bracing, classical guitar or nylon guitar, we usually have at the beginning a long dipole, and then the cross dipole, and then the long dipole. But in other type of instruments, such as, for example, an X-brace Martin, the long dipole and the cross dipole are very close together. And this is because there are the two tone bars, oblique, that are very strongly interfering with what the table would like to do. And then you have the tripoles. It's always like the tripoles are always after dipoles, and you are in the range of usually from 300 to 600 hertz. And these are also very strong radiators. They produce energy, acoustic energy, and they really have an effect on the sound of the instrument. Then again, it depends on how the soundboard is built, because if you have a high mass bridge, and soundboard is very thick, so the monopole mobility will be low. And usually when you have high mass, you lose energy on high frequencies and you lose energy on dipoles and tripoles. But it really depends on the way that the guitar is built. And this is also very clear on the frequency response. For example, in this case, you see two different guitars that have identical shape and identical woods. And this is really a good example of what you can specify with a technical sheet. Because if you look at an internet site, these two guitars are identical. It's Dreadnought, the dimensions. Shape is exactly the same on the shape of the body, the shape of the soundboard, and the bridge. Woods are the same. It's rosewood, Indian rosewood, and Sitka spruce for back and sides and the soundboard and the bridge, ebony bridge for both models. But performances are completely different. In blue, you see the frequency response of the D28, which has much higher frequency of the two modes, of the air mode and the monopole. And in red, you can see much lower frequency for the first two modes of the Larrivée. And also, if you see here at 400 Hertz, you can see there is a very clear peak. This is what I was talking about. It's the long dipole and the cross dipole, which on the D28, this is a D28 non-scalloped bracing, around the 80s. So it's not the pre-war D28. It was a guitar that I had available to measure. But anyway, we can see that this peak here is very clear. It's very evident. At 400 Hertz. And this has an effect, an important effect on the sound, on the mid-range. Also because not only here, but also here and here, you will see that there are still activity. This soundboard is producing higher order modes. It's much more lighter than the Larrivée soundboard. We are at 79 grams instead of 103 grams. A big difference. This is the equivalent mass of the soundboard, and it is not measured by weighting, in fact, the soundboard, because, of course, I don't want to destroy. I will show you. This is one of the monopole parameters that you can easily measure in the shop. And the equivalent mass, in fact, is the part of the soundboard, of the monopole, which is effectively vibrating. It's inside. It's the blue one that we already saw in the simulation. And if you look at these two frequency response, you can see that these two instruments are completely different. The Larrivée has a heavy soundboard, doesn't have higher order modes, almost none. So much of the SPL is coming from the first mode and the monopole, which are also very low in frequencies. And it has a very smooth sound, of course. When you play this guitar, you have no wolf tone because the mobility is quite low. The soundboard is very heavy. So interaction with the strings is very low. It's quite good to be played for a little bit of finger picking. You can strum it because it's very heavy, so it's very difficult to saturate the soundboard. Generally speaking, I don't like this instrument, but the owner of the instrument is the same of the Martin D28, and he loves both guitars because they're very different, in fact. The Martin D28 has a very powerful voice, very rich mid-range, a very nice projection, but still the monopole mobility is not very, very good, because if you see the deflection, 0.09 millimeter kilogram, it's the stiffness of the soundboard. At low frequency, even if the box is big, it's a big box, at low frequency, there is not a lot of SPL produced. When you play the sixth string finger picking, you don't have this feeling of a big body, in fact. But it is very powerful. The sound is really thunderous sound. So it has this type of character. But anyway, you can see a lot of information from one graph, and three frequencies.
Giuliano, can I ask a question really quick?
Yes, of course, please.
So when you say higher order modes, is that related to like the harmonic series above the fundamental? Are you hearing more overtones with the guitar as a result of that, or am I misinterpreting that?
No, it's okay. It's like this. In fact, when you look here, or also when you look here, higher order modes are everything which is over the monopole. Dipoles, tripoles, and then there are also 6 poles, 8 poles. The table is fractioned into small parts. And all of these modes are usually in between 300 and 1 kilohertz. And if you look at the strings on the first graph here, okay, here, we are talking about the first and the second string. So higher order modes are the resonances of the soundboard that are supporting first string and the second string, producing sound, amplifying, in fact, the sounds of first and the seconds, and of course, also the partials of those notes. Because when you play a note, you have fundamental, which is the frequency, the actual frequency of the note, but all the partial at higher frequency. So if you see a soundboard in this graph, the black one, it's that guitar. It's a Martin X bracing style guitar. It's an OM. You see that the dipole are very evident. There are big peaks. It means that this soundboard is in fact producing energy that can amplify first strings and the second strings. That gives you plenty of, in fact, overtones.
Cool.
Otherwise, if you don't have these resonances evident in the frequency response, it means that almost everything that you hear comes directly just from the strings, but not from the soundboard, because the strings themselves, they produce sound, of course. At high frequency, the sound radiated by the guitar is just a string. I have a picture, not here in my book. I just recorded, in fact, the frequency response of the soundboard and the frequency response of the guitar, strummed guitar, and you see that a lot of energy is coming just from the strings. So it is not that if the soundboard doesn't have very clear dipoles, 3 poles, 4 poles, 6 poles, there is no sound at high frequency. Of course there is, but it's just the strings, and it is like the feeling is like having a separation. You have a hole in between, because in fact the soundboard is not producing sound at mid and high frequencies. Okay, it's okay like this. Other questions before proceeding? Okay, so I go on. About the monopole parameter, in order to measure, you need just this jig. It's a micrometer that is designed to be positioned on the top of the soundboard. I can show you here, in fact. I have another guitar that I'm building right now, and I cannot see my video here, but it should be okay like this. Ian, you can pin that the
Yep. 1 second. Let's see. I'll have to stop sharing screen.
Yeah.
I do have questions, Giuliano. I have thousands of them, but I'm going to wait until I'm finished reading your book.
No, but you can interrupt. Huh? It's not a problem. We are between us, so it's interesting to Anyway, you can see the jig. In fact, there is a micrometer here, and in fact, the jig is just holding the body of the micrometer, and the pin of the micrometer is connected to the small table over the micrometer. So when I put it here over the soundboard with some interface, because of course it's quite delicate. Okay. The structure, in fact, is just holding the micrometer over the soundboard, and I can apply a weight, reset the micrometer to 0, and measure, in fact, the deflection of the soundboard. Of course, a little care is needed because you don't want the weight falling into the soundboard. I guess it is, yeah, you can clearly see, in fact. In this case, we have still the bridge is missing. So we have a very high deflection. It's almost 0.2 millimeter for, this is 1 kilogram of mass that I use. And in this case, I have the deflection, which is 0.2 millimeter, almost, yes, 0.2 millimeter. And the second thing that I want to do in order to calculate the other parameters of the monopole is to measure the resonance frequency of this table, of this board, just closing the so you can see me in the first camera now. I have my microphone, I have my analyzer. This is Room Wizard connected to the microphone. Oh, it works fine. So I just measured the resonance frequency of the board. I need to close the sound hole because even if
Giuliano, is there any way we can see the computer at the same time? Do you want to share a screen on the?
yes, just a moment. Okay, I'm sharing this one, share. Okay, this is Room Wizard, and here I am with the microphone close to the sound hole opening, and in fact I am highlighting the first resonance. This is the air mode, and now I can see it very high in SPL because with the microphone I am really on the sound hole. Of course, there is a proximity. And if I put the microphone at the center of the soundboard, I repeat the measurement. Now the first peak is disappear because I am in close field with the soundboard, so I have a lot of energy coming from this resonance here. This is the resonance of the monopole of this guitar, of this body as it is right now. It's not finished, of course, but this is an information. And if I close the hole here and I repeat the measurement, usually the frequency of the monopole is a little bit lower, and this is 222. 222 is the resonance frequency of just the soundboard, not coupled with the rest of the system. So I can go to my calculation. Sorry, I'm trying to. Okay, I have to open here, share the screen. Okay, this is an Excel spreadsheet which is available for download. I can put the data that we just measured together. I have 1 kilogram of loading mass, 0.2 millimeter of deflection. The monopole surface, it's very similar because it's always NOM. It's 222, the resonance frequency. The resonance frequency of the monopole. And so I have equivalent mass. So actually, the mass of this part of the guitar, it's just 25 grams. And the monopole mobility, which is 28.5. It's crazy high because, in fact, the bridge is missing. When the bridge will be glued on, we will add 20, 25 grams, it depends. And we will go to 45, 50 grams of equivalent mass, which is very good for a nylon string guitar, considering that other commercial guitar, for example, I have a Taylor 814 CE that has 70 grams mass of the monopole. We know the Larivé, Martin M28 is around 78. So when you are at 50, you have a very light equivalent mass. But anyway, it's just a quick demonstration to show you how you can measure the equivalent mass of the monopole and get a lot of information about how the guitar is built. Is it an heavy soundboard? It is a light soundboard. It is a very stiff bracing system or less stiff bracing. All of these information are very simple to be measured. And it gives information that can be resumed in a simple manner. If we go back to the PowerPoint, and we go back to the specifications.
Hey, Giuliano.
Okay. You just have the equivalent mass and the monopole mobility. The monopole mobility is just one number that gives you an idea of how light and responsive the guitar is. That soundboard here, it's still not finished. The bridge is not glued on. We are at 28. And in the case of a finished guitar, here we are around 10.8. It's less than half. So it gives an idea about how lightly and responsive the instrument is. Doug?
Yeah.
You were asking.
Doug had a question. Doug, are you there?
Oh, Ian, it was you that you were talking?
Yeah, no, I had a question.
Doug had a question.
Are you that spreadsheet where you were showing all of the difference between the different guitars and all of these kind of measurements? Are these measurements being taken strings on or strings off? In other words, I know that obviously the measurements where the bridges are not on the guitar, that's obvious. But if you do these measurements on a customer's guitar or on a pre-existing guitar, like a Taylor or Martin or whoever's instruments on your bench, how different are the measurements under string tension versus off string tension when there's a load on the top?
There is no big difference. The measurement that you see here are with the strings on, under tension. The difference with tension of the strings, it's just the first time that you string a guitar, and the first time that you stretch, in fact, all the system, all the body, the soundboard, the necks, all of the assembly. In fact, there are some changements that you can in fact measure, but then once the body has settled down and it has taken its form, there is no difference. And in fact, I suggest to perform this measurement with a complete instrument, with the string on under tension, of course. In this case, the measurement that you see here are under tension. The only thing is that you need to remove a little bit of tension is to plug the hole, because you need to measure the resonance of the soundboard without the hole, because the hole is pushing the resonance of the soundboard a little bit higher, the resonance of the air, because in fact the two resonances are pushing themselves a little bit. So you need to plug the hole, and to do this, but you can use in fact the rubber plugs, and maybe you can also you can position under the strings, but otherwise you have to remove a little bit of string tension. But anyway, the string tension is not modifying the resonance frequency of the soundboard, or nor the mass, nor the stiffness. In fact, you need to measure the mass of the soundboard with the pins and the bridge, because this is really affecting a lot the resonance frequency. If you take a measurement of a complete guitar, as you usually do, I just use that body, but usually you take a frequency response of the guitar, you can hold it like this, or you can also put it like here. You just don't have to touch the back of the instruments, and it is very, very simple, very comfortable to use, to measure a frequency response in this condition. Then you just put on the table. You have to ensure that it is stable, of course, and you put your measurement jig for the deflection testing, like this, of course. It works very well. Then you just have to plug the hole, and it's very quick. Then
Doug,
again, yeah.
Oh, I was just gonna say, Doug, that I think what he's saying is like a lot of the measurements are a ratio. So like it doesn't matter if the strings are on, because the top deflection is going to be whatever percent of the weight and the deflection, right? Am I getting that right?
Yes.
Like it's going to deflect the same with or without string tension on, even though it's. Is that right?
Yes.
Okay.
String tension is not changing the stiffness of the soundboard, and the deflection measurement is the same. I mean, of course.
So the string pull of a full set of strings of 160 or 180 pounds pulling on the top would effectively change the shape of the top. And being under load would not change the frequency response of that any given piece of wood?
Slightly, but just a little bit, not so much.
Okay.
Not so much. We can do it if you want. We can try.
No, it's fine. I was just asking for clarification. I find it fascinating. Thank you.
Yes, but
it is somewhat
yes.
counterintuitive. I feel like it does feel like it should change the entire dynamic of the.
What really changes is when you remove the saddle, the pins, and the end pins of the strings, because all of these parts, if it is bone, it's more than 10 grams. So it really has an effect on the dynamic of the system, and I will show you. I'm going to show you. So if we go back to the presentation, okay, I'm continuing quickly. So we already talked about this. The sound signature, in fact, of the instrument. There are some standards that you can trace, generally speaking, on classical guitar, acoustic guitars, archtop guitars. This is the way all of specific type of acoustic guitars has a specific sound, because their resonance are usually positioned in frequency ranges that are determined by the style of music that is played with. And it is just a confirmation of how loud a frequency response can talks about the sound of a guitar. And yes, you can see here, Ian, all of the higher order modes, peaks, that can also influence the sound of an instrument. When you see a frequency response like this, immediately the first mode, air mode, the monopole, soundboard monopole, all of the others are higher orders. Even if you don't know anything about the guitar, even if you don't know dimensions and shapes, even if you don't know if this is a dipole or a tripole, you can clearly see that there are peaks. And these peaks means that the soundboard is light, that the bridge is not heavy, and that this guitar will play a lot of overtones, will have a very rich sound, but it is maybe very light, so it's not a guitar that you want to strum vigorously. And maybe being lighter, it is also a guitar that can have problems with wolf tones, because the lighter the soundboard, the higher is the amplitude of wolf tones. Wolf tones are really related to interaction of the strings with the soundboard. So if the soundboard is very heavy, you have a low output, but very smooth output. If the soundboard is very light, there is a lot of interaction with the strings. So it can be a lively instrument, but it can also, you have to pay attention. So it talks a lot, the frequency response graph. Of course, you need to build your experience, measure some guitars, and relate the measurement with the sound you need to play, measure, and build your database. How to shift frequencies. I was just so now that we have seen a general overview about these three type of measurement: frequency response, cladding patterns, monopole parameters. These are the three big blocks of measurements. How can we use, in fact, this measurement on the repair shop? I prepare some example just to get into the real life of the repair shop. So the small mods tuning, this is something that I don't know if what type of repair shop is in fact practicing daily, but this is really something kind of usual. Installing a pickup, switching bone and switching saddles and pins from plastic to bones. All of these interventions have an effect on the tuning of the instrument. And very often I hear that, yes, you have to change from plastic to bone, it will change the sound. Of course, it will change the sound, not only because of the transfer of the vibration from the string to the soundboard, which of course it is better with a stiffer material with lower damping. Of course, bone, it's a better material than plastic. Plastic, it's not stiff, and it is damped. So in fact, it's eating a lot of informations that are on the strings. This is clear. But also you are interfering on the resonance system, which is the monopole. Because when you are adding 3 grams or 4 grams on a table, you are really in the range of modification that can change from a wolf note that is not there to a very strong wolf notes. This is a simulation tool that is also available. When you buy the book, there is a link to download this small piece of software. And here you can insert the parameters that you measure with the technique that we just saw. And you can simulate just by changing and switching, changing a little bit. You can simulate how the first 3 modes are changing. I have the tool here open, so I just need to switch, stop sharing, and I go here. MATLAB. Okay. Okay, so this is the piece of software. You can download if you buy the book. If you don't, you just send me an email. I can send you the link. You just have to install a freeware software that is needed to run the program. It's quite simple, so it's free. And here you have all the parameter, the mass of the top, the back and sides, the mass of sound hole here. There is a description of how you can insert all of the values for a standard guitar. In this case, what you see here is that OM guitar, which has in fact mass of the soundboard equivalent mass of 74 grams. And if I add 6 grams, for example, which is the difference between plastic and bone saddle and pins, usually, I go to exactly 80 grams. And in fact, I am moving the resonance frequency of the monopole from 180 to 175.9. And I'm getting close, very close to 174, which is in fact the frequency of a note on the scale. It should be the F. And also, as you can see, all the modes are coupled. So also the first mode is shifting a little bit. So this is the theory, and it's interesting to have a small tool that can simulate changement on the frequency response of the instrument. In the practice, what is the consequences of this changement? We can see it here. Share. Okay. RTA. Okay, it should be here. Share. Okay, so now you can see the measurement window for the system that I have here. So let's take a frequency response of this guitar to begin with. Okay. Okay, so what is interesting for us are these first 3 peaks. This is the air mode. This is the main monopole. And this is the active back. As you can see, we are very similar to what we already saw on the simulator. Simulation is, if I can share the screen, maybe could be more simple. Okay, so if I do like this, and then I remove this, I remove this, and I have to run this.
Giuliano,
Yes.
ask a quick question about the software right there. Is there a way to label in the software what those peaks are, like, right, 91 hertz above the first one and 187 on the second one?
It's here. It's here. You have it here, aside. Resonance mode. You are talking about simulation or the measurement?
Just when you take a measurement.
When you take a measurement, you have the cursor. So you're just here, and you see here 107.
Well, I know, but is there a way to write it in there so when you save that, it's stored exactly what it was?
No, there is no way to write in there. But
Okay.
anyway, you can compare different curves. There is no actual automatic recognitions of the peaks if you're looking for this, but you can read it.
Okay.
And you can compare different curves.
You could also maybe annotate it, like do a screen grab of it and just annotate it if you need to.
Right. I mean, that's what I do now, but it would just be real nice to be able to. You can't on any other software I've found either, but I just thought maybe I was hopeful.
I mean, I don't know what software are you talking about.
He was saying you.
Huh?
And the RE, what is it? REM, REW, whatever.
I mean, yeah, of course, there are a lot of different software out there. For me, RoomIQ Wizard has a lot of possibilities, and usually the way you use it is on the main window where you compare different frequency response. And yes, you don't have the exact specific values for each peak, but you can compare, you can measure it, you can note. Anyway.
Right. Yeah. I just write it down, but I would just, it would be nice if they had a feature in there where you could label exactly what it was and save it that way. But
okay, so coming back, you can see that the frequency response that I simulated is very similar to the frequency response that I'm measuring. And still I have the three peaks, the back, the monopole back, the monopole of the soundboard, and air mode, which is very good, very interesting. It means that the software is working well. And if I, oh, so I'm sorry. If I continue and I keep the curve that we just measured here on the screen, and I am double checking how this guitar relates to Wolf tones. In fact, I see that the monopole here is at 180, here 179.8, but around 180, which is very good as a positioning for the monopole, because we are exactly centered in between two notes of the scale. You see in this table that the F, it's F3, it's at 174.6, and the F diez is 185. So exactly in between these two notes, I am at 180. And this is where I want to be, because this is a situation where the Wolf tone produced by these two notes will be at the minimum. If I go back to the software, I can double check this just by going to 4 average, and I can play the guitar on the frequency response. So I guess that you don't hear the notes, right? Because it's a filter from Zoom.
Yeah, it's getting cut. It's okay though.
Anyway, maybe if I talk in between, you can still hear something.
Yep.
If I approach to the frequency of the monopole, it's the 4th string. I can see that up to now, the peaks are very clear. I have still a good decay, a good sustain, in fact. I approach here, and I still keep a peak shape, even if I see something at the frequency of the monopole. Can you see it?
Yeah.
It's not a perfectly symmetrical peak. Here it's perfect, but it's just because I am far away from the resonance. The more I go close to the resonance, but still it's distance. And now, in fact, I am on the other side. In fact, I can see that the peak of the monopole is centered in between these two notes.
Isn't that something?
Okay?
What would
Is
happen
it,
if you were to
is it clear, right? Uh-huh.
What would happen if you were to slightly bend the string into the resonance frequency?
We can see what happens if I change the frequency of the monopole. It's the
Okay.
same thing. Just look at here. Imagine that here I have 3 grams of added mass, and I put it here, and this is just simulating switching from plastic to bone for the pins.
Okay.
If I measure again now the frequency response with 3 grams added mass, just one moment, I go to 32.
So you're very close. So you've got the simulation and then your actual resonance testing overlapped, correct?
No, this is
Oh, okay. Okay.
the red one is a standard guitar. The black one is plus 3 grams. I put 3 grams on the bridge with some putty. This is the difference of adding 3 grams on the center of the soundboard. So the monopole is going from 180 to 175. Just 3 grams of mass. And if I add other 3 grams of mass here, I put it here on the bridge. I measure again, I keep the black one. And now I am around 174.9, and now I am really very close to a note. So let's see, I just keep this measurement, and let's see what happens with the 6 gram added mass on the bridge. I switch to 4 average because it's just quicker. Okay, you see that now we are exactly on the monopole, and here I have wolf tone. I have no peak anymore. I have 2 peaks, in fact. It's cut in half by the resonance of the monopole, which is exactly on a note. And of course, the decay is very quick. So now here I have my peak. If I go down, you see? And now you don't, obviously you don't feel it, but I am here. And now I have a strong wolf tone here. So I can see very clearly on the measurement, I can feel it. And it is due to the fact that I added 6 grams on the center of the monopole. So every time that you add a pickup, for example, or that you change the configuration of saddles and pins, or that you shave a little bit the bridge, every time that you change something at the center of the monopole, you are shifting a little bit the frequencies, the resonance frequency of the system. So it might be that the guitar that you have is not perfectly tuned. Very often it is like this, and maybe you can improve the situation on the wolf tone. Maybe you have a big wolf tone, and by changing something here, you can make it better. Because if this is the starting point right now, and you add a little bit of mass, you will reduce the amplitude of a wolf tone. But Anyway, you have to be aware that intervening on the soundboard is shifting the frequencies, the main frequencies, and it's not really affecting the tone of the guitar, because generally speaking, the curve it's very similar. You see here, you still have a very clear long and cross dipole, and this is a very clear tripole. This guitar has a good presence of higher order modes, and this has not changed a lot with the added mass. In fact, if I remove now both mass from the bridge and measure again the frequency response, I'm going to 32. In fact, I can see that, you see, just a little bit more evidence here, but generally speaking, the curve is the same. What is really changing here is that the tuning of the main monopole and of the A resonance is slightly different. And if you look at the curve, it might seem not a big difference, but you just saw what is the difference on the notes that are in the scale. Because in fact, the point is that at those frequencies, the notes are very close together, and the difference is just some hertz. So if you are perfect at 180 and you shift by 2-3 hertz, it's not going to be a big difference. But if the guitar is very responsive, you will feel it. But if you are, for example, at 168 and you shift by 3 hertz, you will get 175, and you will get a very strong wolf tone. So it might be also that some customer can ask for some modification of the sound. Does it happen sometimes, Ian, Doug? Do you have customers that comes with a guitar and ask for a changement? I don't know, some annoying wolf tones.
Well, yeah, I do have circumstances, and that this whole thing is got all sorts of ideas rolling around in my head. But there are times where someone will come in with a guitar, and they'll say something to the effect of, "Oh, I can't put my finger on it, but there's something about the voice of this guitar that is not, doing what I think it could or should or whatever it is in their mind." And having this kind of ability to visually demonstrate to a customer what the guitar is and isn't doing in a quantifiable fashion has all sorts of fascinating possibilities. The big question I have that keeps coming, that I keep wanting to ask, but I don't want to interrupt you too much, is, what are the changes to a standard Martin, Gibson, Taylor, Yamaha, whatever, that you could make to demonstrably change in one direction or another what that customer's, kind of asking to change. You follow me?
Yes, of course. But for example, you can work here. You can see scalloping the saddle is changing by 1-2 grams, and shaving a bridge also can arrive to 2-3 grams of differences. In this case, you have to keep in mind that you want the resonance of the monopole is always in between 180, 190, 200, 210. This is the range of frequency of the main monopole of steel string guitar. So in this frequency range, the difference between the notes is a couple of hertz. So in order to improve the behavior of a wolf tone, you need to shift the frequency by, in the best case, 2-3 hertz, maybe 4, maybe 5. You have to test, of course. And in order to get this difference, you need some grams of difference. It's not a big changement. And if you need to go down in frequency, it's very simple, because you just need to add a little bit of mass. It's really very simple. And as you saw, 3 grams, 4 grams of mass on the center of the monopole, it's not affecting the rest of the sound of the guitar. You are just cleaning out the wolf tones, and the sound of the guitar will remain almost untouched. Going down, it's very simple. Going high, it's a little bit more delicate, because you need, if you want to shift the resonance frequency of the monopole higher, you need remove mass, and it's not simple to remove mass, or increase the stiffness. Generally speaking, increasing the stiffness, I would say it's almost impossible, because to increase the stiffness, you have to add some bracing inside, or to increase the height of a bracing inside. It's really, I would say, almost impossible. But reducing the weight, it's feasible. You can work on the bridge pins, on the bridge saddle shape. And in this case, for example, you can see that scalloping the saddle is reducing the weight of 1.3 grams. And it's a small difference, but when you play the instrument, it can go really far away. And then I would say it's up to you.
I think also the visual representation of what any given change in the guitar happens to the guitar in a measurable aspect, I think could also serve repair shops in a huge way for those circumstances where you have, I mean, we all know that we're working on guitars for a living, and attached to them are guitar players who are all insane. So, when a customer comes in and, you have that nervous customer that's worried about whatever it is you're going to do to their guitar and what a quote unquote effect it's going to have on the sound, to be able to have a visual representation of, if you bring in a guitar, that you have X number of repairs that you need to do. So you can measure what the guitar looks like as a visual representation of the frequency response of the guitar. Before you affect the repairs, you can do those repairs, and you can have a visual representation of what they look like after, and easily point to them and say to a customer, look, I haven't changed your guitar.
Yes.
In terms of the inherent voice that's in the instrument. From a visual standpoint, you can just look at it. You can improve the guitar. If you get a guitar that comes in with 6 loose braces on the top, you can pretty much well bet that it's going to be a much more responsive guitar when you get them all glued up. But I like the concept of having this to be able to demonstrate to a customer, especially those high maintenance customers, to be able to physically show them, here's your guitar before and here's your guitar after.
Exactly.
Giuliano, can I sneak in a quick question?
Of course. Go.
Is when people complain about guitars that are out of balance, maybe they just kind of favor a note or favor a key. Is that just a subtle form of wolf note, or is that something different?
It might be a lot of things. Yeah, it depends. Usually wolf notes in certain instruments are almost wolf note free. For example, the Larivé that I showed you, theoretically the resonances are really very close to notes, but due to the fact that the soundboard is very heavy, the guitar is not really producing strange resonances. This is also maybe why industrial guitars are usually heavily built, because the sound is not really dynamic. It's not really something to die for, but usually you don't have issues, you don't have problems. When you have a very responsive guitar with a light soundboard, you really have to take care of positioning of the resonance mode, because wolf tone can be very strong, very annoying, and can really make the sound unpleasant. Then out of balance can also mean that, yes, maybe the soundboard can be too stiff. And sometimes when the soundboard is very stiff, the instrument sounds muted. Because in fact, one thing we are right now, we are just looking at the graph. We are beginning to discuss all of this, but a lot of what we are seeing right now has to do with the interaction between listening and playing. Because when you play the guitar, you are doing something and you are expecting something in return. You are touching a string, you are feeling the vibration, and you want to hear the sound. So some times ago, I was working on archtop guitars on some prototypes, and the first model that I built, the first prototype that I built, was really not good. I didn't like it, and it seemed that the strings were stiffer than usual. But it was very strange because the scale length was the same, and it was the very same set of strings. I wanted to be sure. I developed a system to measure, in fact, the force that was necessary for the string to touch the fret at the 12th position. And it was identical to other guitars that I had here. But when I played, the feeling was really, I really have to push with the fingers, because in fact, the guitar was not producing sound. So with other instruments that are more shifted toward the low ends, you have a body, you have a warmth, and when you play, you have something in return. And so from my point of view, when people talk about a soft neck, it's really about the balance of the sound of the instruments. And the feeling is that something is changing on the neck, but in reality, it's really the sound that is produced by the instruments that is interacting with the playing and with the playing experience, with the listening experience and playing experience. So all of this is quite delicate. It's complex. But generally speaking, yes, of course, you can analyze. The first thing that you ask to your customer is, give me your guitar. I can measure it. You can measure the frequency response. You can check the monopole mobility. You can describe the instrument. Okay, the instrument is okay. So maybe talk to me, try to explain better what you think. Or maybe you can find that the instrument is strange. You see here, I don't know, maybe you see here you have, you can do, as Doug was suggesting, you can compare the instrument with another one, if I can find it. No, I will not find it. And with the comparison, you can really explain here.
Yeah.
You see your guitar is on the blue. Maybe you want something that has more low hands. In this case, I cannot do anything because this is really the guitar that you have. So you cannot touch this instrument because this is what it is. But you can explain why. And already explaining why is getting you in touch, in connection with the customer. But for me, this is something that also the store, the selling store would have an interest in doing. This is something that I am thinking to propose also, because when you see a wall of guitars, everything is the same, but it is not in reality. So how to understand where to focus? Imagine for a seller, a retailer, a guy that is working on a shop that can help himself with a graphic like this to show to the customer what is proposing to him and helping the customer to choose also. But anyway, this is another discussion, but something that I think it's very interesting.
Well,
Please,
it sounds like Doug is already gearing up to adopt what you're doing. So I think that's a good start.
I think
Do you
this
have
is really, I think this is really cool. I'm like, I just started reading the book. For some reason, it took a while for Amazon to get it to me. But I just started reading the book, so I look forward to digging into the materials better. I'm just curious about what kind of I can see this. And since you do this, Giuliano, I presume you have a workstation set up so that you can just drop a guitar down, do these measurements, save them in whatever fashion, and then move on. I'm just curious about what the gear up requirements would be for being able to set up a station like this. So not only I could do my own testing, but in some way be able to demonstrate live to a customer, what's going on here. Because I think that's probably the biggest hurdle is, the customer education part of it. It's hard enough sometimes to get a customer to realize he's got to press his finger up against the fret when he's playing a C so it doesn't buzz. So this seems like a big leap from there.
yeah, of course. But anyway, about the setup of the shop, it's very simple. This is my setup, as you can really see. It's really something that it's not taking a lot of space. And this is also why I'm suggesting to use this instead of other tools, because this microphone, the mini DSP microphone, it's this microphone. It's USB connected to the computer. So in order to have the system running, you just have your cable. The microphone is in its box, in a drawer with this support. You just take the microphone out, you put it on the edge of the table, you connect it, and the computer that I'm using is, I have all the folders and the software that are shared on Google. So I have a laptop, I have a fixed workstation here, because today I'm using the laptop also because I have 3 different sources, but usually I have this screen with a mini PC on the back, the cable, which is always there. So I just have to take the cable, connect to the microphone, and take my hammer. It's really quick. And then I put it back on a drawer. So I don't have additional cables to make this measurement. If I need to measure the monopole mobility, I have this jig that I have on the wall here. So after all, it's really not a lot of stuff, and the way you can and you will insert in the workshop. It would be interesting, as I told you, and everyone else, to think about standards, also to produce maybe some jig and some support dedicated to this kind of analysis. I know that you're really into this stuff. It will be interesting. For me today, I have so many things to do that it's not my it's my first interest, but of course it's interesting. Anyway, even if you don't, it's very simple. It's really some simple stuff.
Giuliano, could you bump it back up to that document that you had before, that I think is maybe what you're referencing in terms of standardizing, maybe for
this document?
No, the one that was like the guitar with the information plus the frequency response, almost like something that you would hand a customer.
This is what I am giving with my instrument. This is a specification sheet that comes with each one of my instruments. And the most important data are the frequency response is the first one. It's the most important. And in this box here, I am adding the monopole mobility, the equivalent mass, and the frequencies of the three modes. Why? Because the frequencies of the three modes is telling me if there are Wolf nodes or not. And here, 90, 190, 205, 257, I am exactly at the center. I'm completely shy of Wolf nodes. The equivalent mass here is 48 grams, and the monopole mobility at 19 tells me that the guitar is very responsive. So then I look at the frequency response, I see that there is this type of behavior, that the monopole is very high in SPL, that the first mode is very low in frequency, but this is closer to the listener because the sound hole is higher here. This is this instrument here. Oh, this is the set recorder. Anyway, this is the chord. It's the same instrument with 6 strings. And for me, when I play, I have the opening which is closer to my ear, but not too much. And this is giving an idea about the sound and the performances of the instrument. And then, as Doug was saying, when I give this to my customer, I'm explaining him everything. And I can tell you, it was what I was telling at the beginning. People are very, very interested because usually what they tell me is the first time that someone is explaining me how the instrument works. And they are very interested also because this is not rocket science. This is something that you can explain in a simplified way, but generally speaking, the customer will understand because generally speaking, the guys that buys a luthier guitar is a passionate guy, is into this. So you are giving him a lot of information. And after that, he can also use the instrument differently. He understands how the instrument works. And once there is a problem, he can come back to me with the instrument. I can take measurement, or I can verify if there are problems. Usually, if nothing happened, instruments are quite stable. Of course, with hygrometry and temperature changement during the seasons, there are seasonal shiftment a little bit. But this is helping building the relationship with the customer. And it's not only for the builder, but also, of course, for the repair shop. Equivalent mass is bridge weight. No, the equivalent mass is the world soundboard that is resonating at the monopole. So equivalent mass is here. Is the mass of this part of the monopole. Is the part of the soundboard that is resonating at the monopole resonance frequency. So it's just the complete mass of the soundboard of the instrument. It's completed together with the saddle, with the pins, and the strings pins.
I apologize. I missed that then. That's interesting.
And I have another question. Is about electric guitars. No, the Wolf tones on the electric guitars. We talk about dead notes. It's a different phenomenon because, in fact, usually on electric guitars there are no huge resonances of the body, such as on acoustic guitars. There can be dead notes, but it's due to other phenomena, other different type of problems mostly related to the bridge and some frets, maybe the nut, or other type of resonances on the body, but it's not the same phenomenon. If you have other questions, otherwise I was just wanting to explore another possibility very quickly.
Yep.
Just as an aside, while you were on the subject of electric guitars, have you done these kind of measurements of archtop guitars?
Yes, of course.
And are there big differences there between
Yes.
that and a acoustic, like steel string acoustic?
Yes, yes. I wouldn't say that archtop guitar for me are still acoustic guitars. If we are talking about the Benedetto style archtop guitars, so the acoustic component is still very, very important. And I in another presentation here I have. I guess it was not here. It was here. I presented more comparison between instruments, and here, for example, okay, here I have. You can see this is an archtop guitar I built some years ago. This is really built. It's a 16-inch lower bout based on the Benedetto design. It's classic New York style design, and also. About also on the acoustical side, it's that type of beast, and as you can see, compared to Martin OM28, the main differences of archtop guitars is that the modes, the air mode and the monopole are shifted higher in frequencies, much higher than with traditional flat top guitars. So you don't have the same body at low frequency, the same resonance, warmth at low end, but you have a lot of energy and dynamic in the mid-range. And this is why this type of guitars were so used live in big bands, because in those situations, you don't want low frequencies, you want mid-range with the higher possible level of energy, really to cut through the band and to arrive to the listener. And if you look at the equivalent mass here, it's 64 grams. It means it's much lighter than the equivalent mass of Martin OM28, which is more than 75, 78. Usually, the fact that there are F holes aside at the bridge reduces, in fact, the active zone of the soundboard, of the monopole, because, in fact, these are cuts that, in fact, when you look at the monopole is really centered on the bridge, and the mass of the soundboard is very, very low. So, in fact, if you look here, SPL is much higher than the Martin OM28, which is in green. You don't have high order modes. You see that 400, 500, 600, there is nothing. You can see, Doug?
Yes.
Yeah, I can see you.
It's very clean, the frequency response, but this also depends on the shape, the doming of the soundboard, and the fact that the bridge is not glued. In fact, you don't have a pull effect on the bridge, and dipoles and tripoles are much lower in energy. So usually archtop guitars really project a lot. All the energy is into the monopole and the first mode. And so this gives really this type of projection and energy in the mid-range of, generally speaking, archtop guitar. Then I measured a lot of situation in between. For example, here you can have still acoustic measurements of 3 different instruments. And there is, again, the OM. And then in green, there is a semicassa, there is an electric guitar with a hollow body and opening. And in green, you can see that there are some small resonances in the mid-range. And then a Les Paul, which is the black one, and it's completely silent. Over 1 kilohertz, there is some noise, but it's just a metallic part coming from the bridge. It's metallic resonances of the body is really silent. Of course, this is a Les Paul, but this in between the blue, there is the OM, and the black, I measured a lot of different possibilities. You can have, for example, Gretsch with the trestle bracing, which is really in between these two. The mobility is very low because the top and the back are glued together, but still there is a powerful activity, acoustic activity. And you can have a hollow body, but with pickup glued on the soundboard. And this, of course, increases a lot the mass of the soundbar and reduces the output, but still you can have a lot of output. It's very interesting for the repair shop also this type of analysis, because for each type of guitar you can make acoustic measurements. These measurements are made with microphone and the same type of hammer, but you still can identify exactly the character. And if you can see something happening on the frequency response, you can be sure that also the electrical output from the pickup is going to be influenced by this, because energy that vibrates and produces sound is not going into electrical signal into the pickup. So it's a very interesting analysis, of course, but yes, there is a lot to talk about.
Giuliano, I have another question.
Please.
On your Brazilian guitar, how you move the sound hole up beside the neck, is that to make your active zone larger?
This is not the first reason, no. The first reason is that in this type of guitars, in all the models that I'm building, I have an overhang neck without the heel on the back, you can see.
Mm-hmm.
And the neck is really entering into the soundboard. The soundboard is bended on the upper bout. It's not a domed soundboard, it's really bended, and the neck is really entering inside. And this is asking me to use a bigger neck block. The neck block is arriving up to here and is extending a lot more than traditional neck guitars. So I am arriving here, and here there is not enough space to open the hole. This is the first reason. Then I don't like a hole being here exactly in the direction of pull of the strings for structural reasons. I prefer to have this part of the instrument in a single piece. And then I wanted also to shift the hole closer to the listener, to the player, because it's increasing a little bit the sound pressure level, but not too much. I am not opening sound holes here, because for me this here it's a little bit too much, at least for the tuning that I am doing. So these are the main reasons for this.
So it doesn't really have that much of effect on the frequencies? No,
because in any case you cannot increase the surface of the soundboard just like this, because even if you make a huge soundboard, the energy coming from the strings is always the same. So you have that energy, and it's the energy that comes from the string that decided how much SPL you get. If you reduce the soundboard, instead you reduce the mass and you can have more SPL. In fact, if you want to have more SPL, it's better to reduce the dimensions of the soundboard than to increase it, in my opinion. And this is why very often people that try small guitars are impressed by the volume that comes out. Then you don't have low frequency because the volume is small, but it's a different reason for this. Anyway, just to finish, for the possibility, the palette of possibility for the repair shop, it's also when you have one problem, and Ian, this might interest you and the Gibson that often gives you problems. You trace the frequency, you look for the frequency where you have problems, you look at the frequency response. If you have peaks at that frequency, this means that the issue that you are having is generated by a resonance on the soundboard. Then you make the Chladni pattern at that frequency. You take the speaker, you set the generator around that zone of frequency, and you move the speaker looking for the shape of the resonance on the soundboard. In this case, it's the long tripole that is producing too much energy in this instrument, around 600, 650. And this sometimes happens because of imperfections on the wood or small differences on the build. And it's really some fine tuning that you can do. But now I see that there is a 3-pole. And if I want to reduce the activity of this resonance without touching the rest of the sound, I am looking for a position to add a small mass. And in this case, it's here, because I up on the soundboard, I am outside the zone of the monopole. So if I put 5 grams of putty there, I am not changing the frequency of the monopole, because this point, the monopole is not active. So I'm really intervening specifically in that resonance shape, and I am not affecting the rest. And in fact, after and before, it's here. Before is in black, and you can see at 650, the peak is much higher. And after is in red, and you can see that in red, I am 6 dB lower in amplitude, and I am following the curve, the gentle curve that is going down. And if you look at 200, 180, 250, 300, all the rest of the frequency response, there is nothing is different, because in fact, I position the putty in a place where I am outside other resonances. This is also a possibility that I have when I need to take care of problems. So you have something strange happening. The first thing, frequency response. Double check if at those frequency there is something on the frequency response. Then Chladni patterns, double checking what is the mode, because sometimes you really, especially at high frequencies, you cannot know what is the mode shape, what is the shape of the resonance on the soundboard. But if you trace the frequency response and then double check with Chladni patterns, you can have a very clear idea of what is happening at those frequencies on the soundboard. And this might be related also to rattling, rub and bats, loose braces, because you know that there are vibrations. You can also do just by touching the table, but it's much more difficult. You can just touch the table when you play the notes, and you feel, in fact, the zone of activities of vibrations. But with this type of technique, you have a clear visualization, and it's very powerful.
That makes a lot of sense.
Do you have something that you want to add? Out of curiosity, something that you still the topic is big, of course.
Yeah.
There are a lot of things to talk about, but the idea of today's meeting that I discussed also, I asked to Michael Bashkin, what do you think? I asked him, what do you think? What can we talk about in the next one? And he said, I think that you should focus on the repair shop. It was very interesting as a suggestion, because you see that there are a lot of possibilities.
Yeah.
For the repair shop, and I dedicated some time to focus on this. And I would say let's consider what we want to discuss about the next time.
Yeah.
I need your input.
I think that once Doug gets rolling, and I'm gonna buy the rig to start testing. I mostly do this now, so I'm not actually seeing a lot of guitars. But I have a couple guitars. I have a Gibson that I know has issues with a couple of the high strings that are just like it's annoying. There's a resonance there that I don't know how to trace back just by ear. So I'm interested in looking at it. So maybe
you're welcome to borrow my setup. I'm not using it at all anytime soon.
Cool. Should we leave it there today and reconnoiter? Does anybody have any more?
I'm fascinated by all of the possibilities of it, because not only will it help in the diagnosis aspect for those, nebulous issues that you're trying to satisfy a customer's needs, but I'm even curious about it from the standpoint of the one thing that for almost 4 decades that I haven't been able to put a finger on or answer the question to for any customer is what will doing X have an effect on the sound of my guitar? And for me, it the possibilities of being able to dispel all of the myths that come with, you know, different aspects of what will change the characteristic of the sound of a guitar and what is, you know, is just a repair.
Yeah. It should be maybe noted that there is a difference between timbre and resonance, though. So, I mean,
Oh, yes.
timbre still becomes
Tone is in the hands, not in the guitar.
tone is in the ear of the batoner, is what I heard.
I think having something close to empirical data on
Yes.
an operation
Like,
will make a client's ears work correctly.
absolutely. You just baffle them with data. That's what I would say. But to that end, Doug, I really think that I see, you know, if you wanted to, a repair document where you take kind of what Giuliano had there with what he's issuing with his I know that you like the detailed record keeping, but if you just, you know, tested the guitar's resonant frequency and produced a document that went along with that guitar so that you could, you know, have a conversation with the customer after the repair and show them here's the before picture, here's the after picture. I mean, that could be super powerful, even in just, you know, not just for troublesome customers, but for just, you know, just kind of overall, you know, feeling like, you know, it's a professional setting and stuff.
Yeah, just for the customer service aspect alone and being able to have that documentation.
Yeah.
Something
Is
tangible.
fantastic.
Anything where, you know, we're able to protect ourselves and, you know, like not just that, but like to do the job better. Like, I don't want to hand a guitar back that has a wolf tone because I put bridge pins on it and I didn't fully understand what was changing. You know, like I think that's good, and probably ought to start doing it. So Max, on the Verzi, I think we'll wait on Verzis and stuff like that for the next one. Giuliano's graciously agreed to hang out with us more often, so we'll leave a little bit of that. I am fascinated by trying to understand in the development of guitars and mandolins in the early days, how much acoustic engineering did those early developers of those instruments, how much were they? I mean, was there somebody at Martin Guitars that had figured this, some of this stuff out, or were they just like throwing a bunch of stuff at the wall? I don't know if you have any of the historical information, but that would be a fascinating thing.
I don't have actual documents talking about it. This is something me too. I am looking for historical documents, but I know for sure that they knew and they practiced more than what we do today.
Yeah.
And my idea is that this is due to the fact that it really was the golden age of industrial building that was close to still artisanal buildings. Then there were a period where just a business comes by, and it was the worst period. The period when no one wanted to buy Gibson or Martin anymore, and it was the same period where small builders began to take the scene. But the thing is that those small builders were beginning from different origins, with a different background, another type of experience. I guess that there were I guess there were a loss of communication between generations in between this
Yeah,
period.
because for the most part, like they looked inside the old guitars and they went scallop bracing. That's
Yeah.
all we got to do is make new guitars with scallop bracing. And
Yeah. But for example, I was listening to the podcast of Greenfield with Baskin, and Michael Greenfield was talking about some bars that were used to tune the guitars in the production line at Martin factory. That today are not used anymore. This is for sure.
Oh, okay. Nate Wood asked about the all the stuff. So on the Amazon page, which you can find on our website, there's links on our website for that. There is a whole section devoted to what Giuliano's up to here, including his book, a link to his book, a link to the specific oregano that he uses, the timbre oregano for getting his patterns on there. So you can find all that on the Amazon page. Yeah. So should we leave a little something to the imagination next time? We've had you for 2 hours. I feel like we should probably let you get back to building guitars and stuff.
May I ask one off the subject question of Giuliano?
Sure. Is it oregano?
Giuliano, well, it's related to the Lent meeting yesterday. Giuliano, you said something about the different weight backs and how they related to the sound of the guitar, and I wanted you to repeat that if you would, because I definitely hear the, and but I would like to think more scientifically about it. Like a heavy rosewood or ebony as opposed to something like myrtle or koa.
I'm sorry. I have a thunderstorm here.
Oh.
Yeah. And sometimes electricity goes down.
Oh.
But anyway, it's not a problem. It's just that my other stuff is offline.
That's all right. We can save it for another time. But another thing I would like to say is I really appreciate the Luth group even being willing to take up this subject, because I've tried to discuss a few things on the Luthier support group and been crucified for it more than once. It's all magic. You can't talk about it scientifically. There ain't no magic. It's all science, and we just because we don't understand it yet doesn't mean it's not there.
Oh, you're welcome here, Chris.
Yeah, we're 3 years in and we're still crucifixion free. So, although I've probably come as close to deserving it as anybody. So,
anyway, yeah. I don't do much repair, but I learned a lot this morning, and so I appreciate it. But I also want to add that anybody wants to start doing this for less than $200, you can start doing spectrograms and buy a Giuliano book and get going. All the things Doug said that he most wanted to do, less than $200. So, and he's already got the book, so less than $150. So.
I think with the oregano, the entire section that is devoted on the Amazon page to Giuliano is definitely.
I have no idea about the oregano. I use poppy seed. So.
Okay.
But that's more expensive if you start doing the Collodny patterns.
Chris,
how does poppy seed change the frequency response of the guitar?
Yeah, I still have to pass drug tests too.
All right. Can everybody unmute and thank Giuliano for shaving off an incredible section of time for us and really bringing fire down from Mount Olympus. Like, this is the second one of these, and I just want to say, like, even even if this doesn't make a lot of sense on the first go around, just keep at it, because I've been looking at this since I was a young Luth, and it definitely, the more you start thinking about it, the more you immerse yourself in it, the clearer it becomes. So if you're struggling now, just keep plugging away at it. And Giuliano is doing a great job of making this very accessible. So everybody unmute and tell Giuliano thank you.
Giuliano,
Thank
you're my
you.
hero.
Well done,
Love
Giuliano.
you.
Thank you.
You.
Thanks,
Thank
Giuliano.
you.
Giuliano. Looking
And,
forward to seeing you in Cremona.
And y'all have a good rest of your day. And Giuliano's gonna, if you want, you can hang out and answer more questions. I got to fix the website. Apparently, the website went down while we were talking, so I'm gonna go do IT stuff.